According to the National Electrical Code, specifically Section 110.26C2 in the 2005 edition, which pertains to access and egress from working space, the requirements for doors depend on several factors. Let's dissect this section to understand the parameters. The core principle revolves around ensuring personnel safety when working on electrical equipment. Working space, as defined by the NEC, is the area in front of electrical equipment such as panels, switchboards, and motor control centers that allows for safe operation, inspection, maintenance, and repair. This space needs to meet specific dimensions for height, width, and depth, dictated by the voltage of the equipment and the conditions present. The depth of the working space, which is the distance from the front of the equipment to the nearest obstruction, is what's most pertinent here. The NEC specifies minimum depths based on voltage levels. For example, for equipment operating at 150 volts to ground or less, a minimum depth of 3 feet is generally required. For equipment operating at higher voltages, such as 600 volts, the required depth increases. Condition 1 exists where there is exposed live parts on one side and no insulated parts or grounded parts on the other side of the working space, or exposed live parts on both sides. Condition 2 is where there are exposed live parts on one side and grounded parts on the other side of the working space. Condition 3 is where there are exposed live parts on both sides of the working space. The specific distances for each condition are outlined in Table 110.26a on. Now, let's address the door requirements. Section 110.26C2 mandates that for equipment rated 1200 amps or more and containing overcurrent devices, at least one entrance to and egress from the required working space must be at least 24 inches wide and 6 feet 6 inches high. Crucially, if the equipment is located in a dedicated electrical room and the entrance to that room is within the working space, then that door must comply with the direction of opening requirement. This means the door must open in the direction of egress, allowing for swift exit in case of an emergency. The intent here is to prevent the door from obstructing someone trying to leave the working space quickly. The requirement for panic hardware, such as panic bars or pressure plates, is similarly tied to the location of the door relative to the working space. If the door is within the working space, and the equipment is rated 1200 amps or more, then the door must be equipped with hardware that allows for easy and rapid egress. However, the crucial point is the phrase "within the required working space." If the door is located outside the required working space, the NEC requirements regarding the direction of opening and panic hardware typically do not apply. In the scenario described, the door is situated 8 feet away from the front of the electrical panel, which is 4 feet 6 inches beyond the assumed 3-foot working clearance requirement. Because the door is outside the designated working space, the specific requirements of 110.26C2 concerning direction of opening and panic hardware do not come into play. The reasoning is that the door's location doesn't directly impede egress from the immediate area where electrical work is being performed. However, other building codes and safety regulations might impose different requirements based on occupancy type, fire safety, and other considerations. It's essential to consider these additional regulations to ensure full compliance. For instance, local building codes may mandate panic hardware on doors serving high occupancy areas, regardless of their proximity to electrical equipment. Similarly, fire codes may require doors to swing in the direction of egress to facilitate rapid evacuation during a fire. In summary, while the NEC provides specific guidelines for doors within the required working space around electrical equipment, these guidelines generally do not extend to doors located outside the designated area. Always consult the latest edition of the NEC and local codes to ensure compliance with all applicable regulations. Moreover, a thorough risk assessment should be conducted to identify any potential hazards and implement appropriate safety measures, regardless of code requirements. For example, even if a door is located outside the working space, it might still be prudent to install panic hardware if the room is frequently accessed by multiple personnel. This proactive approach enhances safety and minimizes the risk of accidents. Now let's consider some additional factors that might influence the interpretation of these requirements. Firstly, the definition of working space itself can be subject to interpretation. While the NEC provides general guidelines, the specific dimensions of the working space may need to be adjusted based on the specific equipment configuration and the tasks being performed. For instance, if the equipment requires frequent maintenance or calibration, a larger working space might be necessary to accommodate the tools and equipment needed to perform these tasks safely. Secondly, the term egress is also important to understand. Egress refers to the ability to exit a space quickly and safely. The NEC requirements for doors are intended to ensure that personnel can egress from the working space without being impeded by obstructions or cumbersome hardware. Thirdly, the presence of other hazards in the electrical room can also influence the need for additional safety measures. For example, if the room contains flammable materials or hazardous chemicals, it might be necessary to install additional emergency lighting or ventilation systems to ensure the safety of personnel. Fourthly, the training and qualifications of the personnel working in the electrical room are also crucial. Only qualified personnel who have received adequate training in electrical safety should be allowed to work on or near energized equipment. These personnel should be familiar with NEC requirements and should be able to identify potential hazards and take appropriate precautions. Fifthly, the frequency of access to the electrical room should also be considered. If the room is accessed frequently, it might be prudent to install additional safety features, such as motion sensors or audible alarms to alert personnel to potential hazards. Sixthly, the design of the electrical room itself can also influence the need for additional safety measures. For example, if the room is small or poorly ventilated, it might be necessary to install additional ventilation systems to prevent the buildup of hazardous gases or fumes. Seventhly, the type of equipment installed in the electrical room can also affect the safety requirements. For example, if the room contains high-voltage equipment, it might be necessary to install additional grounding systems or barriers to prevent accidental contact with energized parts. Eighthly, the age of the electrical equipment can also be a factor. Older equipment may not meet current safety standards and may require additional maintenance or upgrades to ensure safe operation. Ninthly, the environmental conditions in the electrical room can also influence the safety requirements. For example, if the room is exposed to excessive moisture or dust, it might be necessary to install additional protection measures to prevent equipment failure or electrical hazards. Tenthly, the location of the electrical room within the building can also be a factor. For example, if the room is located near a fire exit, it might be necessary to install additional fire protection measures to prevent the spread of fire. Remember that code requirements are minimum safety standards. A well-designed electrical system will often exceed these minimums to provide a greater margin of safety. Consider the specific hazards present in the electrical room and implement appropriate safety measures to mitigate those hazards, regardless of whether they are explicitly required by code. Some examples of safety measures to consider are, firstly, regular inspections and maintenance of electrical equipment to identify and correct any potential hazards. Secondly, the use of personal protective equipment, such as gloves, safety glasses, and arc-rated clothing, when working on or near energized equipment. Thirdly, the implementation of lockout/tagout procedures to prevent accidental energization of equipment during maintenance or repair. Fourthly, the installation of ground fault circuit interrupters to protect personnel from electric shock. Fifthly, the provision of adequate lighting in the electrical room to ensure safe working conditions. Sixthly, the posting of warning signs and labels to alert personnel to potential hazards. Seventhly, the training of personnel in emergency procedures, such as how to respond to an electrical fire or shock. Eighthly, the development of a comprehensive safety plan that outlines all of the safety procedures and practices to be followed in the electrical room. Ninthly, the regular review and updating of the safety plan to ensure that it remains current and effective. Tenthly, the involvement of all personnel in the safety process to foster a culture of safety.